So in this video, we are looking at 9618 variant 42 of October, November 2024. And this is going to be the Java implementation to question number 1. All right, so question number 1 here reads, a computer game is designed for users to select characters. Each character can take part in a group of events. Each group has 5 events. There are 4 types of events: jump, swim, run, drive. The program is written using object-oriented programming. So part A says here that we are given a class diagram there. The class is going to be called event item. Then it's going to have 3 fields and 4 methods, including the constructor. So we have to write program code to declare the class event item and its constructor. Then of course we are not going to declare any other methods. So I think it should be 4 marks for this. Yes, it's going to be 4 marks for this one. So here's the implementation. So I have my code in one file. It's called question 1 n24v42 Java. But then for you, when you answer a question, you need to make sure that you store it using this format. The reason why I name my files like this is because I have this one parent folder where I have all the solutions for all the papers. So to avoid naming conflicts, you have to specify the variant as well as the year. So inside of this file, I have a class called event item right there on line 52. So this is more like just a class definition. It's got no logic in it. Rather, it doesn't have the main method, is it? So I'm just declaring the class as it were. So you can actually do this in Java. You can have your classes in the same file, but the main class is the only one that you're going to declare as public. Otherwise, all the other classes that you're going to have going on in there should just be classes. There should be no access specifier, as it were. So here's the event item class with the event name as a string, the type as a string, and the difficulty as an integer. Then of course here's the constructor. Remember, in Java, the constructor name should always match the class name, and the constructor should always be public. Then of course we are setting the event's name to the event inside of the class there. So we do this rest, the same for the rest, that is for the type and the difficulty. And of course, you'd go ahead and copy this code and paste it inside of the evidence document. Moving on to item number 2, we have to write program code for the 3 get methods. So get name, get difficulty, and get event type. So let's go ahead and look at that implementation for the getters. So we have the getters running from line 64 to line 74. So we have the get string, we have the get difficulty, rather the get name, the get difficulty, and the get event type. Again, these ones you can automatically generate them using your IDE by just pressing generate. I think it's generate or insert, depending on the IDE that you are using. Then moving on to part B, we have an array group code group rather that stores 5 objects of type event. So we have to write program code to declare the group local to the main method. So let's go to the main class. Again, remember we have all our code in one file, right, in one Java file. So the main class is this one with the question number. And then inside of that, that's where we are going to have our main method. So the main method, we are declaring that global array, rather that local array called group, and it's going to hold event item objects as it were, and the size is going to be 5 as specified right there in the question. Alright, then moving on to B item 2, we have the events table. So the name of the event, then the event type, then the event difficulty is it. So we have 5 events going on there. So we have to write program code to create an instance of the event type, event item for each of the 5 events and store them inside of the group. So we have 5 entries. The way you read this table is that we have 5 entries. So the event name, we have bridge, we have water weight, we have the 100-mile run, we have the gridlock, and we have the wall-on-wall jump, right? So this one is a jumping event, this one is a swimming event, this one is a running event, this one is a driving event, and so forth and so on. Then the difficulty levels are set here for each level, for each event as it were. All right, so for the B item 2 implementation, that is creating event item objects, we simply now create a new instance of the event, right, by calling the constructor from the event item class. Then we pass the arguments that are required. So we have the event name, the event type, and the event difficulty. Then we are going to store that as the first array element inside of the group array that we just declared on line 8 there. So we do the rest for the other events, right? So notice that we use zero-based indexing in Java. So that's why we are starting at 0, 1, 2, 3, and 4. Then moving on to the next question, we are to create a character class, right? That is the following attributes and methods. So the attributes, we have about 5 attributes, and we have 3 methods, is it including the constructor. So the first part is always going to ask you to declare the class and the constructor, as it were. As well as the get method right there. So let's go ahead and look at that implementation going on here. So I have my character class down here. So you see that we have the 5 attributes, 1 string and 4 integers with the appropriate or with the matching identifier names right there in the class diagram. Then we have the constructor going on there. Then of course we have the get method for the name, that is. So you go ahead and copy this code and paste it inside of the evidence document. Then moving on to D, we have the method calculate score that is going to be inside of the character class, and it's essentially going to calculate and return the percentage chance of a character completing an event. So when a character's skill level is greater than or equal to the difficulty of that event, the percentage chance of completing the event is 100%. Basically, this is what they're just saying, is it? So when a character's skill is less than the difficulty of that event, the character's skill level is subtracted from the difficulty of that event. This difference is used to identify the percentage chance of using this. So basically, we're just saying that if the skill level is greater, it's going to be 100% chance of completing it. Then if the skill level is lower, we are going to compare the skill level and calculate the percentage chance of success. So here's an example here. If a character has a skill level of 3 for events of type run, then an event of type run is a difficulty of level 5. So the character's skill level is less than the difficulty, therefore the difference is calculated. So the difference is going to be calculated by saying 5 minus 3, which is 2. Then from according to this table there, if the difference is 2, then the character has a 60% chance of completing the event. We are to write program code for the calculate score, and it's going to take the type of event and difficulty as parameters. So let's actually do it step by step. Coming back to the implementation here for the calculate score function, you see that we have the event type as a string and we have the difficulty as an integer. So this is the function header there. Then we are to calculate the percentage chance of the character completing the event. So for this, we are going to be using a switch case, but initially we need to set the skill level to 0 so that we start with an empty skill level. Then what we are simply going to do now is we are going to remember that for this particular class, we have these integers going on, the jump, the swim, the run, the drive, is it? So in the event that the event is say jump, we're going to take the value of jump and store it as the new skill level. Then we do the same for swimming, for running, for driving, and so forth. Then of course, in the default case that we have nothing that matches any of the events, we simply break. Then we continue to calculate the percentage chance of the character completing the event. Now that for that part, we first have to check if the skill level is greater than or equal to the difficulty. In that case, we simply return 100% because they say that if the skill level is greater than or equal to the difficulty level, then the percentage chance of completing the event is 100%. So that's what we're doing there. Here on line 118. Then for the rest of the algorithm, we need to calculate the percentage chance of the character completing the event. Right, then return the percentage chance of completing the event as an integer number, for example 60. So we need another skill. We need another switch case, right? In the event that the user, or rather the skill level is less than the difficulty level, right? So we are going to perform this calculation. So we are going to take calculate the difference, right? Difficulty minus skill level is described right there in this example. So we now have a value for difference. So in the case that difference is 1, then there's this 80% chance that we're going to succeed. Then in the event that it is 60, we are going to, rather 2, we're going to return 60. In the event that it is 3, we return 40, and so forth and so on. So score is going to be initialized, rather it's initialized here, rather it's declared on line 122, but it doesn't have a value. Then we are going to initialize it depending on the situation, whereby the difference is 1, 2, 3, 4, or default, is it? Then of course that's it for the switch statement. And yeah, you then go ahead and copy this code and paste it inside of the evidence document. The code is quite long, not because it's complicated, but because of the switch case statement. I could have actually used a newer Java notation whereby you don't have to make use of the three lines, that is the case, the skill level, and the break. Is it? You can actually just do it using one switch case, one line in a switch case statement by using the arrow function that was introduced in Java. It should be Java 20, but I think maybe I'll show you that notation later on. But you can always use this one. I think I did this one in my tutorials, so you can always use this one. So that's why the code looks a bit long, but really it's not that complicated. Then of course you copy and paste the code inside of the evidence document. Now moving on to part E, two characters are attempting each event in the group you created in part 1B. So one character is named Taz and the skill levels are 5, 3, 5, 1. Then the second character is Jenny and the skill levels are 2, 2, 3, and 4. Each character object is stored in a variable. Then amend the main program to declare and create an instance of a character object for Taz and Jenny. So let's go ahead and look at that implementation going on in our main class there. So we have the main function right here. We have the implementation for E item 1 right there. So we are instantiating new character objects. There's Taz and there's Jenny, right? And we are passing the appropriate parameters to the constructor there. So 5 for swim, 3 for 5 for jump, 3 for swim, 5 for run, and 1 for drive. That is for Taz. Then 2 for jump, 2 for swim, 3 for run, and 4 for drive. That is for Jenny. Then, of course, you copy the code and paste it inside of the evidence document. One mark for creating each object. Then item number 2, both Taz and Jenny take part in each event in the group you created in part 1B. So remember the group, this one, right there. Then these steps are repeated for all 5 events. So the percentage chance of each character completing the event is calculated and compared. Then the character with the highest percentage chance of completing the event gets 1 point. Their character name is output together with a message telling them they won the event. If both characters have the same percentage chance of completing the event, the scores do not change and the message is output string. Rather, is output stating that the event is a draw. When the total score for each character has been calculated, the name of the character with the highest score is output stating they have won and the number of points they have. If both characters have the same number of points, a message is output telling them the group is a draw. All right, so basically we have to amend the main program that it's going to calculate the score for each character in an event. Then it's going to output the name of the character that wins each event, or that the event is a draw. And it's going to output the name of the character that has the most points for the group, or that the group is a draw. Again, you need to remember that this is going to happen for all the 5 events, is it? So there's definitely need for us to make use of a loop. And I would suggest that you do a little bit of forward planning for this one because it's worth 7 marks. So let's look at the implementation going on right here. So I'm using an enhanced for loop, right? Initially, I'm going to set Taz's points to 0 and Jenny's points to 0. Then starting our enhanced for loop here, we are going to iterate over event item objects, and we are going to be taking the group array right there. So initially we are going to calculate Taz's score for the swimming, rather jumping first, is it? So jump, swim, run, drive, is it? So we are going to calculate for jump, then we get the difficulty, then we set Taz's score there. Then we need to check who has won. So we are doing this for both players, right? For Taz and for Jenny, getting their score for a particular event and their difficulty for a particular event, and then after which we move on to compare and see who won in that particular event. So if Taz's score is greater than Jenny's score, then we simply increment the point. We assign Taz a point there. Then we say that Taz won the name of the event there, right? Else it means that Jenny is won, so we assign Jenny a point. And then we get the name of Jenny, rather the event. Actually, the name of the character, then the name of the event as it were. Then in the event that neither of these conditions are true, that is to say they are both equal, we simply have that else going on there. So this is going to repeat 5 times, is it? That is for each event, for the events that we have going on here. So we have This is going to be for the 5 groups that we've declared right there. So it's going to happen 5 times. Then in the end, ultimately, we need to determine the overall winner, right, for each group. So this is what we are doing right there on line 38. We are checking to see if Taz is more points than Jenny. Then we tell them that we output that they with the group with this many points. Else Jenny has won with this many points. Then else it was a draw, right? So that's the implementation for, or rather the amendment for this part. B item, wait, was it B? B item 2? E item 2, sorry, E item 2. Then after which, okay, right. After which we need to run our program and take a screenshot of the output. So let me just go ahead and open the terminal right here. Make sure that I'm starting on a clean slate. Then the name of the file is Java. That's question 1 November. Yeah, this is the file. So let me just hit enter there. Give it a minute to this thing. Then yeah, you see there's the output there. So Taz wins bridge. Taz wins water weight. Taz wins 100-mile run. Jenny wins gridlock. Taz wins war on war. Then Taz wins the group with 4 points. Is it? So yeah, that's just about it for this implementation. Hopefully you learned something, and I'll see you in the implementation for question 2.